This is lesson 4.2, exponential functions. And the objectives are exponents and their properties, exponential functions, solving exponential functions, and solving exponential equations. Okay. What is an exponential function? An exponential function is basically an equation where the unknown, x, is up there as an exponent. Well, normally x is, not an exponent. So that basically classifies what an exponential function is, where a is the base and the variable is the exponent. Okay, so let's kind of review exponents here for a moment. And let me just minimize this. All right, we know that, let's look at properties of exponents. I'm going to use this other board here because then I can refer back to it and not erase it. All right, properties of exponents. Well, we know, let me let Jalen in. Hello, Jalen. Okay, properties of exponents. If we have something like 2 to the third power, well, that's 2 times itself 3 times. So that's 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. The 2 is the base, and 3 is the exponent. Okay, so if we have, so that's one property. So if we have a to negative exponent, that's 1 over, what you get here is you apply the reciprocal to that. So basically you flip it, what we commonly call flip it. So that becomes 1, that negative exponent. The whole purpose in life for that negative exponent is to move that base a down into the denominator. So it becomes 1 over 8 at the end. Well, let's look at an example. Let's say that 2 to the negative third power will be 1 over 2 to the third. The negative exponent brings that 2 down into the denominator. So this is 2 to the third. We already said that was 8. So that becomes 1 over 8. Next, we have a to the 1 over n. And that makes it a exponential expression. So you get a to 1 over n is the nth root of a. Well, normally, n, we don't see the number here, and that's square. That means square root. So in other words, if we had 2 to the 1/3 power, for example, this would be the cube root of 2. Well, 2 times itself, nothing will give you 2. Nothing times itself 3 times will give you 2. So that's as simple as you can get. You can't simplify that any further. All right. Next, you have a. Use the other one. A to the m over n, and so the n, the denominator, that's your root, and then m, that's your 8 times itself. So if we had here 2, use black, 2 to the 3/4 power, then the denominator, that's your root. 2, that's still your base, to the 3rd power. Well, 2 to the 3rd power is 8. So that's the 4th root of 8, and nothing times itself 4 times will give you 8. So that's all you can do there. Okay, so that's properties of exponents. So let's take a look at some examples. So let's say here we have 16 to the 3/4 power. Okay, well that's going to give you a radical. Whatever's in the denominator, that's your root for denominator for your exponent. And so that'll be 16 to the 3rd power. Well, you can put either the 3rd power on the inside, or you can put it on the outside like that. Well, since 2 times 2 is 4, times 2 is 8, times 2 is 16, we can say that the 4th root of 2 is 16. So the 4th root, so we can say 2 to the 4th power is 16. So these two are inverses, they cancel out. We still have to the 3rd, so that'll be 2 to the 3rd power. Well, we said before that 2 to the 3rd power is 8. And so that's our answer. All right, any questions with that? All right, let's try another one. And here we have 27 to the negative 1/3 power. Okay, anytime you see a negative exponent, you bring that base down. So that'll be 1 over 27. And then you make that exponent positive. So that's 1 over 27 to the 1/3 power. And we said before that when you have a rational exponent like that, it becomes a radical. So the denominators are 3, so that'll be your root, 27. Well, what times itself 3 times is 27? Well, 3 times 3 is 9, times 3 is 27. So that's 3 to the 3rd. So we can say 1 over the cube root of 3 to the 3rd power. And so the root and the exponent are opposite, they cancel, right? That's the same thing as if we said 1 over 3 to the 3 over 3, which is 1. So our answer is 1/3. Okay, questions there? Okay, next is 64 to the negative 1/2. And again, because it's a negative exponent, we have to make it 1 over 64 to the 1/2 power. So it's a rational exponent, so we're going to change that to a radical. Well, we don't normally write the 2 here for a square root. It's implied that if there's no root there, that it's a square root. So we can get rid of that 2. Well, the square root of 64, right, is 8. 8 times 8 is 64, right? We know that 8 times 8 is 64. So we can say 8 squared. So that's 1 over the square root of 8 squared. So the square and the square root cancel out, and we get 1 over 8 is our answer. Okay. Any questions with that? All right. So let's say that we want to find a different type of problem. Okay, here we have, here we're saying if f of x is equal to 2 to the x power, and we want to find f to the negative 1. So we substitute this negative 1 in for x. So it's like we're cutting the x out and put parentheses, and cut this out, x out, put parentheses there, and we substitute in negative 1, this number here. Negative 1, negative 1. So we get 2 to the negative 1 power, and because it's a negative exponent, we've got to move that 2 down into the denominator. And so that's just 1/2, and that's our answer. Alrighty. So another problem is, let's say, same function f of x equal to 2 over x, and we want to find f to the third. All right, so f to the third will be 2, and where that x is, we put 3 in there. Make that a little clearer. We put 3. Well, 2 to the third, that's 2 times 2 is 4 times 2 is 8, right? So our answer is just 8. And that's all we have to do there. Okay, well, let's say, again, we have f of x equals to 2 to the x power. And we want to find f of 4.92. All right, well, this one you have to use the calculator. So this will be f to the 4.92 equals to 2 to the 4.92 power. So you have to use your calculator. Okay, so you can use the calculator on your cell phone, and all right, let's see if I can change this to scientific. No. I'm trying to see if I can use this as a scientific calculator. Without having to. All right, I'll just have to. Now, one thing I'll tell you is that I would recommend that you can get a TI-84 calculator on your cell phone for free. Just go to your Play Store, your Google App Store, type in TI-84 calculator, and download it. So I'm going to go to my TI-84 calculator, and here we go. Okay, and I gotta darken this a little bit so you can see it better. There we go. Get out of there. Okay, so I'll just put that up there. So we put in 2, and then this exponent looking button here, and we put in 4.92. Oops. 4.92. So you can see up here, you can see there, 4.92 is up at an exponent. And it gives you 30.27, and they want you to round it. Well, they don't tell you what to round it to. Let's see. On the homework, they usually tell you to round it to 2 or 3 decimal places. Let's see. Oh, all right. Well, sometimes they have you do it as a fraction. So if you have to make it a fraction, you can go to math, and then 1 for fraction, and then enter. No. Hit enter. All right, back up. Delete. All right, let's start over. 2 exponent 4.92, and then hit the right arrow. All right, enter. Okay, and then so you can hit math, frat for fraction, and you get 16. Oh, okay, so you can't get a fraction from that. But anyways, you get a decimal. All right, 30 point. We'll call it 30.27. Okay. So any questions with that? All right. So, all right. So let's take a look at some additional properties of exponents. So additional properties of exponents. All right, and we can say that if we want to solve for exponential equations, if a to some exponent b equals to a to some exponent c, then we can set, if the bases are the same, then we can set the exponents equal to each other. All right, so, but the bases have to be the same in order to do that. All right, so let's take a look at a problem. And we want to solve for 1/3 to the x power equals to 81. Okay, first thing we want to do is change the fraction to a negative exponent. Step 1. Change any fractions to a negative, so that it has a negative exponent. So this 1/3 becomes 3 to the negative x power equals to 81. Because we said before that x to the negative n is 1 over x to the n, right? So we're going back the other way, and that's what we did here. Okay, next thing is change any radicals to rational exponents. Well, we don't have any radicals, so we're okay there. Change the bases. So next thing we want to do is change the bases so they are the same, to be the same if possible, so that you can apply a to the b equals a to the c, and then you can set your exponents equal to each other. So therefore b equals c. So we want to see, can I make 81 3 to some power? Well, we know that 81 is 9 times 9, right? And 9 is 3 times 3, so, and that would be 3 times 3. So we can say that 81 is 3 to the 4th power. So that means that we have here 3 to the negative x equals to 3 to the 4th power. Now that the bases to our exponents are the same, we can apply properties of exponents by setting the exponents equal to each other. So therefore, since the left exponent is a negative x equal to, and then the right exponent is 4, so that's going to be on the right side. Well, we've got to isolate that negative, so we have to divide by negative 1 to both sides. So that negative divided by negative is a positive, and that x goes away, and then the negative goes away. Positive 4 divided by negative 1 is a negative 4, and that's our answer. So if we were to check it, and we put in one third to the negative, so if we were to check it, we put 1/3 to the negative 4 power equals to 81. That negative exponent is going to apply the reciprocal, so that becomes 3 to the 4th. So that's going to flip that 1/3, right? It's going to apply the reciprocal. So 3 to the 4th is 81. So 81 equals 81, and it checks. Okay? Alrighty. Okay. So let's try another one. So here we have 2 to the x power equals to 8. So this one's a little bit easier than the last one. So we ask ourselves, can I apply a to b equals a, if a to b equals a to c, then b equals c. Can I get these two bases to be the same? So the question I ask is, can I make 8 2 to some power? Well, 8 is 2 to what power? Well, 8 is 2 to the 3rd. So our base on the left is the same as our base on the right. So we can set the exponents equal to each other. And so our answer is x equals 3. And that's all there's to it. All right, let's try another one. Let's say we have here 5 to the negative x power equals to 1 over 125. Well, we want to change this fraction to a negative exponent. So this becomes 5 to the negative x equal to 125 to the negative 1 power. And so now we ask ourselves, is 125, 5 to what power gives us 125? Well, we still have that negative 1 there, so we have to include that. And the left side, that doesn't change. Okay, well, 5 to what power is 125? Well, 5 times 5 is 25. 25 times 5 is 125. And so we can use 5 to the third power. So that becomes 5 to the negative x equals to 5 to the third power times negative 1. And so that'll be 5 to the negative x equals to 5 to the negative 3. So now our base on the left is the same as our base on the right. So we can set the exponents equal to each other. So that's negative x equal to negative 3. But this x is not isolated completely. So we have to divide both sides. We can either multiply or divide by negative 1. I like to divide by negative 1. So negative divided by negative is positive. Negative divided by negative is positive. So we get x equal to a positive 3. And that's our answer. Okay. Questions with that? All right, just one more problem. And we'll be finished with this lesson. Oh, we did that one already. Okay, well, let's see what's on the homework. If there's anything weird. Okay, well, here's one. Let's say that we have 36x equals to 6. Well, we want to see if we can apply if a to the b equals a to the c, then b equals c. We want to see if we can apply that property of exponents. Well, this is 6 to the first power, right? So we want to see, can we make 36 6 to some power times x? And this is 6 to the first power here. Well, 36 is 6 squared, right? 6 times 6 is 36. So that's 2x. So our base on the left is the same as our base on the right. So we can set the exponents equal to each other. 2x equals to 1. And then solve for x. When we solve for x, we divide by 2. Divide by 2. And we get x equals to 1/2. And that's our answer. All right, any questions there? All right, here's another one. Let's say that we have here 2, and then parentheses, we've got 7 minus 3x. Close that. Equals to 1/4. Okay, so we said before that if we have a fraction, we want to change that to a negative exponent. So we're going to bring that 2 to the 7 minus 3x down. We can change that to 4 to the negative 1 power. And so we ask ourselves, 4 is 2. Can we make that to where it's the same base as the left? So we ask ourselves, 2 to what power gives us 4? We should have said 2 squared. So that'd be 2 to the 7 minus 3x. So the base on the left is the same as the base on your right. So we can set the exponents equal to each other. So that's 7 minus 3x equals to 2. 7 minus 3x is the exponent on the left. Put the equal sign. 2 is the exponent on the right. Now we solve for x. So we have a positive 7, so we apply minus 7 to both sides. And we get a negative 3x equals to, you got a positive 2, negative 7, you get a negative 4. And now we have a negative 3 times x, so we got to divide by negative 3. Divide by negative 3. And we get x equals to negative, divided by negative is a positive, 4 over 3, and that's our answer. 4 over 3 is our answer. Okay? Questions there? All right. Oh, wait a minute. That's a negative 5. I'm sorry. It should be negative 5. Negative 5. So that should be negative 5 over 3. And that's a negative, and that's a negative, and so that's a negative. So that becomes a negative 9. Okay, so that negative 9 over negative 3, and so that's 3. So our answer is x equals 3. Okay, so did double checking on that, and we found that to be something else, a little bit different, but a good thing we checked it. Okay. Compound interest problem. We have amount equals to principal times 1 plus r over n to the n power, where p is principal, a is future value, the value after interest, r is your interest rate, and n is your compound period. So if annually n equals 1, semi-annually n equals to 2, because there's 2 compounding periods, and semi-annually would be 6 months. Quarterly, there's 4 quarters in a year. So this is the number of compounding periods in 1 year.